I bet. What's up, Musa?
Hey, how's it going?
You doing good, bro? You doing good?
Pretty good, pretty good. Lovely
Cool.
Saturday, randomly cold.
What's up, Mark? But yeah, so we're gonna go over some JavaScript, go over some cool stuff. So, Mark, real quick, I talked to Musa about what we're going over today. We're going over Memoize. We talked a little bit about it, but now I'm going to show you how to implement it and why it's useful. So we're going to go over first with, so you know what a factorial is, right?
Yeah, just a number multiplying itself. So you got 20 times 19, 19 times 8, or times 18, all that, right?
So like this is, so it's like 20 times 19 times 18, dot, all the way.
All the way to 1.
So to do this, like this is like the classic interview question, that they ask at like Amazon and stuff, like, hey, do you understand recursion? So a quick way to do this would be write a function here.
Yep.
We'll just call it factorial, and it takes a number.
An argument.
Yep. And what? So when you do recursion, you need a base case. Otherwise, it'll just loop forever.
Yeah.
What is our base case in this situation? So if it's like factorial 5 times 4 times 3 times 2 times 1.
Well, obviously, if you have 0, it can't do anything.
Because you can't, if you multiply by 0. So what's before 0?
1.
1, sorry. So if number is 1,
Yep.
triple equals 1, we want to
Turn that back.
return 1.
Yep. The syntax is really cool, by the way, just on the single
Oh,
line.
this, yeah. That triple equals wrong, so we just want to return 1 there.
Yep.
And then, so now what do we want to do?
You want to go through, well, we probably just want to have like a function that we can call that,
So factorial is already a function,
Yeah,
and
it's already-
recursion
yeah.
is calling itself.
it's calling itself, that's true.
So we could do return, we could return n. You know what, let's just change number to n just because it's easier to type.
Yeah.
We'll return n,
Times n minus 1, or factorial.
and we pass in n minus 1.
Yeah. Because we're calling itself, and if it's 1, it returns 1, but it's factorial. Oh, because it keeps looping
Does it?
through. Yeah,
Okay,
it keeps
so-
looping through, yeah.
So like if you pass in 5, so it'll be 5 times factorial 4. So it's already holding on to the 5.
Yep.
Now it's going to the 4, so when you pass the 4, it'll then go 3.
It'll
so
do another instance of factorial, and
so
then,
it'll bubble all the way, so it'll be 5 times 4 times 3 times 2 times 1.
yeah.
And then because we have the base case, so that'll return the 1 there. So then we'll just multiply everything by 1. So let's double check this real quick. Let's copy and paste this. So we'll do factorial 3. That's 6. 3 times 2 times 1.
Yep.
Let's do 5. 120. I'm going to assume that's right because,
Let's try it. Let's try our let's see if our base case. Let's see if that works. I mean, just 1.
Well, I mean, if there's no base case, then it would return times minus 1 times minus 2. It would just infinite loop forever.
Yeah.
So we know the base case is working. But, so now over here, we can see how, like, if we do factorial 999,
Yeah. It's infinite.
I mean, it's not quite infinite. I'm going to guess it is here. But let's do times 123. You see how this is like a huge number?
Yeah.
Now let's assume that this is a very expensive function in terms of time, and we want to cache this value. That's where Memoize comes in.
Okay.
And so what Memoize does is it returns a cached version of a function. So for example, if we have, let's call it Memoize, and let's just return an empty function for now.
Okay.
We'll do the implementation in a second. But so the way we want to use Memoize is we want it to accept a function, and it'll return a function.
Okay. So it returns that function that we pass in.
I mean, we're gonna do more implementation with it, but the way we want to use it is we're gonna do mem Let's do const cached factorial equals mem factorial. This is how we want to use this function.
Yeah, I saw that.
So for memoization, where would you want to find, or what would you is there like, I mean, for besides factorial, where would there be like the easiest or the most real world case you would use memoization for? Like,
so a real life example of Memoize, something that might be useful. So say you're doing, I would say a React app, and you don't have a simple React, not even a React app. Let's just say you have a simple JavaScript app, web page, and and you need to do an API call.
yeah,
And you know that the API, whatever it's returning, isn't going to change based on the arguments that you pass in. So given the certain arguments, you're going to get the same result every time.
Yeah.
But you know that APIs are expensive. It takes maybe 200 milliseconds for each call. Then you connect, then it talks to the server, then you return that.
yeah,
So what you want to do is cache that result. Now, if you don't have like a caching solution or like a state solution, like Redux in React or NGRX in Angular. So this would just be kind of a simple way to do that. So an example can be, so let me do it here in code. So like say we have API call gets same result every time. And we know we're going to hit this over and over again.
Yeah.
Well, if we know it's not going to change, what if we make the API call and then we store the result? And then what we'll do is next time we make the call, we check the store to see if the result is there. If it's there, we then return that version. If it's not there, what we'll do is we'll take the result, like we'll
we'll go through the API.
We'll go through the API, we'll crunch the numbers, whatever the API needs to do, and then we'll store that result, and then we'll return it. So that way you're saving time in this particular example.
Yes.
So,
Time is money.
time is money, exactly. Because we're storing it in terms of space, space is cheap compared to compute power. If you're running a server, it's the processing power that generally costs the more. That and these days graphics cards because of shout-outs to crypto. Shout-outs to crypto. So cool. So what we're going to need is we're going to need a cache or a store. Let's just call it cache. And this is an object. So now we have, and we know we want to return the result, some kind of result.
Yeah.
Well, that'll come later. So we went through two scenarios. The first scenario being if it's in the cache, we return the cache.
Return the cached result.
And then the other one is if it's not in the cache.
We run through the API. Yes.
So this function over here, it takes arguments, right? Because you understand how closures and lexical scoping work.
Yeah.
So just for example, when you invoke a function or you have a closure, it'll actually take the surrounding environment with it.
Yeah.
So over here we'll have, so we know we're returning a function. Right?
We're going to return a function, yes.
Because that's what this cached factorial is here on line 16. That's line 12.
This will be the it'll return a function call
Which has access to this cache. Because it's in the closure.
Okay.
Yeah. So we're returning a function, and this function takes arguments. Like for example, factorial takes n.
Yep.
So let's just call that r for now. So what do we do?
We wanna, so we pass in a factorial, right? Which is gonna be our function call. They're correct. So we want to return a call, I think factorial, if I remember correctly.
Well, let's go back to our two cases. Our cases are, is it in the store?
Yeah.
Then we return it from the store. So first we want to check if it's in the store.
Yes.
So we'll do an if statement. If cache. Now what does the cache have?
Or if cache has the result we're looking for, just.
And so how do we get the result? How do we know? We look at the argument.
Oh, okay.
So if cache are, because cache is just an object.
Yeah.
So cache arg.
If it contains that key, right?
Yeah. So arg is the key.
Arg is the key. Okay.
So if that exists, we want to return cache arg.
And then else, we would just run through the expensive API.
So then we would call the function with the arg.
Oh, we call the you're right. We
So
call
now
the function with the argument, so it runs through that instead.
But we also want to store it in the cache, so we can do
so
cache arg
equals or the returning function, whatever function returns, right?
Mm-hmm.
From the arg. Oh, okay.
And then we would then return
Cache arg. Still right.
Yep.
That makes sense. Okay.
Is this taking setup right here or no? Or is
So
this gonna be
the whole setup.
Okay, so what if?
Let's test this though, right?
Yeah, let's test it.
So before we return this, we'll console log.
Yeah, they're on that laptop right there.
So we're gonna console log here. We hit the cache.
So we hit the cache if the argument's already in there.
Yeah, and then also we did not the cache. Right? So whoops, I hit save. We're not saving this. Let's copy this and then we'll test it out. So now we'll do const fact equals mem. We'll pass in factorial. So just for proof, it's we had factorial 3. That was 6, right?
Yeah.
Now let's do fact. We'll do 3. Now we're using the cached version, so it won't hit the cache because it doesn't exist yet, right? So we expect it to give us 6, but we expect it to console log that we didn't hit the cache. Now let's do it again. Now we expect 6 again.
We expected to hit the cache, right?
Yeah.
And it did. Ah.
Boom. That's an actual practical version of closures that they always ask in job interviews and everything.
Yeah, because I always just say like function with a function usually, and I guess that sort of gets there, but they never really seem to like. Yeah, that's definitely more practical. Practical use case there. So what if? Okay, I'm trying to think of a question. What if well, what if your object has like multiple? Well, what if your cache has like multiple like keys, and therefore you just probably just get the structure? Okay, never mind. I'm trying to think of an easy way to kind of like go through that. You know what I'm saying? Like,
So there's a couple situations where we can make this better.
yeah.
One would be we should probably stringify our arguments.
Yeah.
We're assuming our arguments are very simple right now, but who knows what our argument
Yeah, who
could
knows
be.
what they'll be.
So we could do something like const, I don't know, sanitized arg equals json.stringify, and then we pass in arg,
Yeah.
and then we just use
Our sanitized argument.
yeah. But we're not gonna. There's no reason to go do that. You get the concept.
But yeah. So it's just kind of at that point, just kind of keeping track of data and just making sure your argument types are valid and all that, which there are a lot of tools to help with that. But yeah, okay.
Yeah, man.
I never really got memoization as a concept, so this definitely kind of helped helping out with that for sure.
So how are you not a partner by now?
I just applied to be part
I'm
of
trying to think of another question.
2 days ago. Yesterday.
Yeah, man.
Yeah, no, honestly, it's a really fair
How did you
example.
get it? I mean, you partner. I mean, you definitely